About Lab 2, we are supposed to show the video of the motion of a falling object, which is dropped from rest, and then analyze this motion using Tracker and use GlowScript to construct computational models based on Newton's second law. These procedures are pretty much the same as Lab 1, but for this lab, we analyze the motion of falling objects, so we cannot ignore the effect of gravity force and drag force. Therefore, we use computational models to do the calculation that includes both the gravity force and drag force to get the position data along the time. And finally, we compare the position versus time graph to analyze the effect of gravity force and drag force on falling objects. This is my video. In my video, I chose a box and let my roommate drop the box from rest, and then I uploaded the video into Tracker and got the position data and also the position versus time graph. And I set the origin of the coordinate system at the place where my roommate held the box at rest, with position y direction points upward. So the box fell in a negative y direction, which corresponds to the curve shown in the graph. And here are some of the data and equations I used for the computational models. And then I went to the GlowScript to build the computational models with the effect of drag force and without the drag force. And this is the code with the effect of only gravity force. I changed the mass of the box to 0.03 kilograms, and since the box is dropped from rest, I set its initial velocity to 0. G is equal to 9.8, and also I set the J hat to determine the positive direction. And B is equal to 0 in this case without the effect of drag force. And also changed the T to be smaller than 0.633 seconds, which is the time range. And since we only include gravity force, the net force is equal to the weight force, which is negative box dot m times g times j hat. And then I changed the equation of calculating the final velocity and position based on Newton's second law. And then I also changed the settings of the arrows. I set the arrow scale to be 6.67, and arrow 1 dot pos equals to box dot pos, and arrow 1 dot axis equals to the weight force times the arrow scale. And since this model doesn't include the drag force, I just didn't change anything about arrow 2. And here are the graphs the code generated. The orange arrow represents the weight force, and the graph below is the position versus time graph. And this is the code with the effect of both gravity force and drag force. This code is almost the same as the previous one. The only thing I changed is the value of B and the net force. I actually tried many times to find the value of B, and I calculated it to be 0.0142. And with this value, the last point of the model corresponds with the observed data. And since we include both the gravity force and drag force this time, the net force is equal to the gravity force plus the drag force. And I also changed the settings of the arrow 2. Arrow 2 dot pos equals to box dot pos, and arrow 2 dot axis equals to the drag force times the arrow scale. And here are the graphs. The orange arrow still represents the weight force, while the blue arrow represents the drag force. And finally, I compared the three sets of data by plotting them in the same graph. The blue dot line represents the observed data. The orange line is the one that only includes the gravity force, and the gray line is the one that includes both the gravity force and the drag force. So we can see from this graph that the model that only includes gravity force has a large diversion from the actual data, and the one includes gravity force and drag force. Meaning it's not very practical to have only gravity force exerted on a falling object, while the gray line and the blue dot line are very similar, so we can assume with the gravity force and the drag force together, the model can really assemble the real-world situation. But there is also a little gap in the middle between these two lines. This is probably because when I mark the average position of the box, in each frame in Tracker, it was not very accurate, and also the box is very thin and makes it even harder to mark the average position. And to make some improvements in the future, I'll probably choose a bigger ball, which is easier to mark the position and make the data more accurate. So that's all for my Lab 2 report. Thanks for listening.